If you want to learn how to take a raw video of the sun, stack it, and then post-process it, and then apply some color and sharpening to it, this video is for you. That was a picture of the sun in hydrogen alpha, and in this video I'm going to share with you my complete step-by-step capture and processing workflow from start to finish. Our agenda today is an overview of my Astro gear, FireCapture, which includes focusing, taking flats and recording a video, and my processing steps in AutoStakkert 3, ImPPG, and Photoshop. What I won't do in this video is do a deep dive into any of the applications that I mentioned, but if there are questions or if you want to see a specific video on any of these applications, please let me know in the comments below. Let's take a look at the gear I used. For my telescope, I used a Lunt 40 hydrogen alpha telescope. My mount is a Skywatcher Solar Quest. And my camera is a QHY5 III 178M mini camera. And then I used a laptop with FireCapture. If you're using another type of mount, such as an equatorial mount, you'll have to align your mount and find and track the sun. If you're using an alt-az mount like I am, you'll want to be wary of field rotation, so you don't want to record the sun for too long. Whichever method you use for your mount, you want to make sure that you can properly track the sun. You can do this without properly tracking the sun, but the effort you need to put into capturing and processing the sun later on will be much higher. My setup outside is extremely simple. It's a Lunt 40 on a Solar Quest mount which automatically finds, centers, and tracks the sun for me. I always install an eyepiece so that I can quickly center the sun in the eyepiece. When I turn on my Solar Quest, it finds the sun for me, and I use the attached Soul Searcher to center the sun if it's not in view. My Solar Quest makes starting my solar astronomy sessions super easy. Then I replace the eyepiece with my QHY5 III 178M mini mono guide camera. When I install the camera, I try to put a little bit of tilt into it by only tightening one of the screws in the diagonal. It's not as great as a tilt adjuster that you can buy, but you'll see that this method actually works really well for me, and it helps me get rid of all of the Newton's rings. After it's all connected, I open FireCapture and I look for the sun. Our next step is to focus the sun. I decrease the exposure way down so the sun's surface isn't blindingly bright. First thing I do is zoom into an area of the sun that I can use to focus. You can do this by creating a region of interest or by zooming in 200% like I do here. Before I start adjusting the gain and exposure under the capture settings, I click on where it says Jupiter and I change it to Sun H alpha, which will optimize our capture settings for a hydrogen alpha sun. Then in the gain and exposure controls, my goal is to make the sun look somewhat bright, but with enough contrast so that I can focus it. Those settings will not be my final settings as I'll have to readjust later on. I use 100 gamma just for focusing, move my gain to 14, and then I move the exposure to about 2 seconds, which lets me see the sun in good light. Then I focus my scope as best as I can. And as we get closer to imaging, I don't like using gamma or gain, so I turn off gamma and put my gain all the way down to 0, and I increase my exposure to around 4 seconds. This won't be my final exposure settings, as we'll change them after I take flats. And the last adjustments I make before doing flats is to play with the Etalon tilt adjuster to try and give the sun more contrast. With my Lunt 40, I don't have to do too much. If I go too far, you can see that the sun just turns white. So my final adjustment is very, very small, and I think what we see on the screen looks good. Next, I create a region of interest around the sun, and this is what my framing for the rest of the session will be. This also allows me to get slightly faster FPS when recording, as well as a smaller file size. Next, we're ready to take flats. There are a few ways of doing flats. One popular method is the defocus method, but I like using the bag method, where I get a somewhat transparent plastic bag, and I cover the lens and hold it in place with a rubber band. You can also use parchment paper or a milk carton or any other opaque but translucent cover that you can put on your telescope that diffuses the sunlight. On FireCapture, I changed my exposure range to the last one so that I can do a multi-second exposure. And for my setup here, I find that 4 seconds is perfect. It's somewhat long for a flat, but this is where you'll need to play with your setup and see what works for you. The goal here is to get the histogram of the flat image to around 60 to 75%. And if the light is diffused properly, you'll see that you can see all of the specks of dust like you do on my screen. And that is the goal. I click on the little checkbox here for flat field, and I normally take between 20 and 25. Once it finishes, you'll hear a beep at the end, and once that's done, you can see that there are no more dust specks on the screen. When I remove the plastic bag, the screen is very bright, but I'm going to change my exposure range back to the sun. By default, it loads at 5 milliseconds, and it looks pretty good. You can update the exposure settings to the moon or even Jupiter to increase the exposure, which I eventually do and set it to 5.14 milliseconds. My goal is to try and get the histogram around 70 to 85% mark because that lets me get a bright sun without clipping any data while maintaining some contrast. And the last setting to look at before I start recording is the capture settings here. I normally take 1000 frames in .ser format. It's a RAW format which takes up a lot of space on your hard drive, but you also get all of that sweet raw data that you can process later on. You can take more frames, but if you have an Alt-Az mount like I do here with my Solar Quest, you'll need to be wary about the field rotation as that could end up hurting your image when you try stacking later on. When done, we press play and let it go. Once recording is done, we can see the file on our Explorer here. It's pretty large. Let's move on to the next step, which is AutoStakkert. So after that last video you saw come out of FireCapture, I recorded a bunch more in an attempt to do a time lapse. Showing a time lapse is not part of this video, but if there's interest, let me know in the comments below and I will work on a separate video showing how I do that. But for now, we're going to select one of these videos, one of these SURF files randomly, and we'll see that once I open it in SURF Viewer, we can see that this is what the output looks like. And at the bottom you can see that it's playing out of 1000 frames, what the resolution is, the 8-bit, and what the recording speed was. So the average was about 40 FPS. And we'll select this one and we'll process this in AutoStakkert, ImPPG, and Photoshop. And by these folders, you can tell that I've already processed a couple of these. So I'm going to process this one, and we have AutoStakkert here. If you don't already have it downloaded, you can download it from AutoStakkert.com. The most recent version is AutoStakkert 3, but the developer has made an announcement on Cloudy Night saying that he is working on AutoStakkert 4, which is pretty exciting. But for now, we will just work on AutoStakkert here. To open the file, I'm just going to click and drag and bring it here. We have two options, surface or planet. I'm going to do surface because we can see the surface of the sun. Planet will work just fine because we can see the whole disk of the sun. We'll leave everything else on this side. And I'm going to click on Analyze, and it will analyze the individual frames. Alright, the analysis took a couple of minutes to do, and we have the quality graph here, and it's actually really good here, especially near the end. A lot of these frames are over 50% mark. Normally I stack 50% of my frames, but in a case like this I could end up going to like 60 or 70%, but I'll keep it at my default 50 for now. I don't do drizzle, I won't do drizzle in this video, and once we're ready, what we need to do is select some alignment points. You can do it manually by clicking around the sun, or you can do it automatically. Select the size of the alignment points to add. I'm doing 200, which is still plenty small, and I'll get around 200 of these dots on the sun. You can always increase it to get bigger dots and smaller number. I try to get between 100 and 200 if possible, and you can mess with the minimum brightness. If you want to look at the individual frames, you can use the scroller here to see what the other frames look like. And as you can see, my tracking on the Solar Quest is really good. The sun does not move much. There's a little bit of atmospheric disturbance, but nothing too bad. So I'll click on Place AP Grid. At size 224, it still placed 149 alignment points. Some of these are comically large, but I will leave them as is. Normally I would do 200 and they end up being much smaller, but there's not a lot of movement on the sun, so we should not have any problems here. Once I'm satisfied, I click on, come back to this window, and I click on Stack, and this will take a couple of minutes to do. Alright, that completed stacking. You can use AutoStakkert to stack multiple files at the same time. It'll do them all in different batches. You can also combine them using pip and then do a massive stacking in AutoStakkert. I'm not going to do that here in this video. So once this is done, you can just close AutoStakkert, and in my Explorer here, I have another folder called ASP50. And here I have the stacked TIFF file that was generated by AutoStakkert. And when I open it, this is what it looks like. It's not very sharp, but we're going to take this into ImPPG and work on it there. The next software on our list is ImPPG. If you don't already have it downloaded, you can download it from this URL here. I'll have it in the description below. And it's really great for solar processing. So I'll open ImPPG and drag it to this window, and I'll open this TIFF file here out of AutoStakkert by clicking and dragging. And it opens here. When you open this, you'll see a rectangular box here. This is the work area for ImPPG, so any edits that you make will only impact what's in the little rectangle. If you want to impact the whole sun, you can just create a rectangle yourself or a square around the sun yourself, and now this is the work area. The only thing to know is that if you go to settings, processing backend, you can switch between CPU and GPU depending on how big of an image your sun is and your computing power for both CPU and GPU. Working on a smaller square may be better, and then you can process the rest of them using this button here called select and process the whole image. But I know that I have a strong enough GPU and I can process the whole sun because the file is not that large. And we're going to do two different types of edits, or three different types. We'll do the Lucy-Richardson deconvolution second, we'll do the unsharp masking third. But first, I'm going to click on this button, the tone curve editor, and we'll edit the tone. When you first open this, the logarithmic scale won't be checked, so this is what it'll look like. You won't really see any data. So the first thing you want to do is click on log so that you can see the logarithmic data. You can also click on stretch. It'll stretch the data for you slightly, but I don't like doing this because then this point here, the curve point here, becomes permanent and you can't remove it no matter how many times you right click. So I'm going to reset this. With that said, I also like working on this in an inverted image. So when we do the inverted brightness levels here, you can see that the background turns white and the sun turns dark, so the whites and the blacks kind of just switch up. And this looks better because we can see, once you start processing this, you'll see that the prominences start to pop out without us having to do any kind of composite later on. And the idea is to just add points to this and play around with this to see what kind of curve you can come up with to make the sun look bright, but also have enough contrast, also be bright around the edges so that you can see the prominences. And this part can take quite a while to do. But I'm going to try and do this by hand and show you just that in just a few minutes you can get something that looks kind of nice, and then later on I will apply the my saved processing settings, and we'll compare what the curve looks like. Right, so just a couple minutes of playing with this. This is the curve that I came up with just by eyeballing the sun. You can see that the sun looks more contrasty. You can see more details here. The prominence is very visible here. More of the prominence is around the edges too. It looks really good. So this is the curve I came up with. One thing I like doing is the very leftmost curve point here. If you play with this, you can change the background color. So if you go somewhere here, you'll see that the prominence disappears. But if you go all the way to the bottom, the background becomes black, which I think looks a little bit better after we colorize it. You can also do that part in Photoshop, but I like doing it here because when we feather around to change how this looks, it looks a little bit better with the black background. And I think the contrast also works really well for the prominence here as well. So this is what it looks like, just eyeballing it for a few minutes. But now if I go into File and Load Processing Settings, as you can see, I have a bunch of processed XML files that I've generated here. I'm going to click on my latest one, and we can compare to what the curve looks like. It won't be too different. So click Open. All right. So as you can see, the tone curve isn't that different from what I did eyeballing it, but I always end up using one of my saved settings files because it just makes things so much easier. My settings files also does the deconvolution and the unsharp mask, but I reset those just so I can show you that you can quickly make some minor adjustments to make the sun look sharper. So I'm just going to increase the deconvolution here, and think that's good. It makes the sun look a little bit sharper. We can actually close the tone curve. We don't need this anymore. And I'll add an unsharp mask. So you can add more unsharp masks here. So one will always be the default, but you can always layer them one over the other. I'll only do one. So I'll change my sigma just a tiny bit. And then the amount of unsharp mask will be like, let's say, like another half. So it's like 57% more than what it is. And you can see that the sun looks very much sharper than it did. The edges look good, the prominences look good, and this is a good final result for me. Once you're done, you can click on File, Save, or Control S. It'll warn you if you haven't clicked this button here that you have not selected and processed the whole image. Do it now. You say yes. And then we can give it a name, and I'll call it Sun ImPPG. And it'll save it as a 16-bit TIFF. Now we can close this, and close this. And in our Explorer here, we have the sun here. So this is before out of AutoStakkert, and this is after out of ImPPG. Looks pretty good. All right, now let's move on to Photoshop. Right, so now we have this TIFF file open in Photoshop, and we're going to colorize it and do some additional sharpening. So if you look at the Channels tab here, you'll see that it's in grayscale. So the first thing we need to do is click on Layers, click on Image Mode, and change it to an RGB color image. And that'll generate red, green, and blue channels for us to manipulate. There are a couple ways of doing this. Some people like creating a hue saturation layer and manipulating the color that way, but I like doing it through Layer, New Adjustment Layer, and a New Curves layer, and manipulating each of the red, green, and blue channels individually through curves. So we'll go to red first, and we'll increase the red just like as much as we can without trying to clip any data, which means that we don't want the top line here to get flat against this. Then we'll start losing data. So it looks pinkish. So now we're going to go to the green. We're going to bring the green down a little bit, and then we're going to go to blue, and we're going to bring the blue down quite a bit, like here. There we go. We also want to make sure we don't clip data here, but I'm making it so that when you turn the blue down, the sun looks pretty orangey, and it looks pretty good. I think this is the color that I normally go with, or close to it at least. I also like doing a second curves layer, and what I do here is I'll just increase the brightness a little bit. I think this gives the sun a little bit more of a 3D color, and it also lightens the sun a little bit more. After filling around with this, I think this is what I am happy with. The edges still look pretty good. The next adjustment layer I like to create is for brightness and contrast. And I'll just bring up the brightness just a tiny bit, like 15, 16, or even less. And what this does is it brightens up the bright spots of the sun, and I think it gives it more of a three-dimensional look. There you go, settled at 12. Now the next thing I like doing is I like creating a new layer out of all of these by doing Control, Alt, Shift, N, and E. What that does is it merges all these layers but into a new layer so that I can work on this next. That way, if I ever mess up, I can just delete this layer, go back to these, and then work on those individually. So I can just hide these for now. And here what I'll do is I'll do Filter, Sharpen, Unsharp Mask. Although we did one in ImPPG, we can do another one here just to make the surface look a tiny bit sharper. Turn off and on. You can see, I think I'm pretty happy with what this looks like. Okay, press OK. Great. Now we can tackle the artifacts that we see here. We can almost get rid of them. The best way to do this, so you select this little magic wand tool here. You select the background sky, and we'll see that it selects everything but the sun. And we want to do a pretty aggressive feather, so we'll just select Modify Feather so we can blend in the background and the sun pretty smoothly. And the feather radius I select usually is around 15. I'll even go up to 20 sometimes if the prominences aren't that large, but I have a large prominence here, so I don't want to cut it off too much. So I'll press OK. It did a feather. And then I'll go back to layer, new adjustment layer, brightness and contrast one more time. And you'll see that it creates a mask out of the outside of the sun. And now if I just zoom in here, you'll see that if I increase the brightness, you can see more of the aberrations, and that's what I'm talking about. And here we'll just decrease the brightness all the way, and the contrast will go up all the way. And what that does is pretty much just gets rid of the aberrations here, and we can't really see it anymore. And when we fit the sun on the screen, you can see that it looks really nice. It blends in nicely. The prominences still look really nice, and I think this is a really good finished product. I hope this video was helpful in giving you an idea of how I capture and process my images of the sun in hydrogen alpha. There are other applications or combinations of applications that you can use for your workflow, such as SharpCap instead of FireCapture, or GIMP instead of Photoshop, or Astrosurface instead of AutoStakkert. The idea is to find a workflow that works for your setup and for your comfort level in imaging the sun. If you plan on imaging the next total solar eclipse on April 8, 2024 in hydrogen alpha, you want to make sure that you get enough practice in so when the day comes, you know exactly what your gear setup will look like and how you will take your images. Processing you can worry about later on, but when the day comes, you want to make sure that you're ready to start imaging the sun. You can also image the sun in white light, as I also plan on doing. The setup is probably the same or similar, but the capture and processing workflow will be a little bit different because we're not trying to get so much surface details other than sunspots, but we won't be able to see prominences or filaments on the sun. Stay tuned to this channel for more videos in everything astronomy, and I also plan on doing more live streams on this channel, mostly to get practice before the April 8th eclipse. I've done 4 live streams so far, and they've all been really fun interacting with everyone who has participated. So join us for the next one where you can ask questions and we can look through my telescope together. If you have any questions about anything I covered today, or if it feels like I skipped over anything, please let me know in the comments below. I hope you'll join me in the next astronomy adventure. Clear skies.